Hi, everybody. Welcome to topic 21, normal distribution. Okay, so what I'm going to begin to introduce in the next couple of topics is what we so-called the normal probability distribution. Okay, so these type of data is a continuous data, and you're going to begin to see this is a little bit different than a binomial. All right, so what is so-called a normal probability distribution, or sometimes I would say normally distributed? That means when a continuous random variable, x, and its relative frequency histogram has a bell-shaped curve. So we looked at the bell-shaped curve before in the previous topic. So when it's when your histogram look like a bell-shaped curve, we actually call that we call that distribution normally distributed. So a normal curve is when a histogram is symmetric and has a bell-shaped curve. All right. So in the previous topic, we're seeing a frequency distribution table look like this here on the left, right? Where this is heights in inches and we have our relative frequency. So given a relative frequency distribution, we can actually use a calculator and grab a histogram, okay? Now notice that the relative frequency below is the same. Your relative frequency here is the same as if I would say this is a probability of your random variable x. So relative frequency becomes a type of probability. So here in my histogram, the relative frequency can also be viewed as probability of your random variable x. So from the introduction of of the concept of probability distribution, we can see that okay, the random variable x can be discrete. Now you can see this can also be continuous, but the relative frequency can actually be viewed as a probability, okay, as a probability type of as a probability questions. All right, so if it's a bell curve shape, okay, if my histogram look like a bell curve shape, then what we got ourselves here is a normal distribution. All right, a few properties about normal distribution. A normal distribution is a bell shape and symmetric about its mean. Very important. It's symmetric to its mean. So the mean here is right smack in the middle. So this picture look a lot like the empirical rule that we saw before, which it is. The empirical rule is, we use empirical rule to help us solve some application problem. Okay, so those questions were strictly geared towards 1 standard deviation above, below, or 2 standard deviation above, below, or 3 standard deviation above, below. Okay, so what about anything in between those standard deviation? So the normal curve allow us to compute the probabilities, okay, of of any type, of our any random variable x that's going to lie in between any type of standard deviation. All right, a normal distribution is completely defined by its mean, mu, and the standard deviation, sigma. The total area underneath the normal curve is equal to 1. The x-axis is the horizontal asymptote for a normal distribution curve. Okay, so this end keep on going to the right, this end keep on going left, and your curve will never touch the x-axis. Therefore it's continuous, keep on going. So what we want to do first is go back and visit standardizing a normal distribution. So rather than finding area or probability under the normal curve for every different mean, standard deviation, and random variable x, what we can do is convert the random variable x into a z-score. So as you can recall, in the z-score, from what we learned before, z-score is a distance that a data is from the mean in terms of number of standard deviations. Okay, positive z-score means the data is larger than the mean. Negative z-score means the data value is smaller than the mean. So if the mean is right here in the middle, all right? So if the z-score is negative, they will be below the mean. If the z-score is positive, that means it's on the right side of the mean. So when we standardize our normal distribution, okay, the mean will always equal to 0. 1 standard deviation to the right, 2 standard deviation to the left. That's 1 and -1. And I believe I drew something like this underneath the empirical rule one time. So when we standardize a normal random variable, we use this formula. So this is actually I actually got this from before. With the mean, it's going to be equal to 0. Standard deviation is always 1 at a time. Okay, so let's kind of review this real quick. Calculate the standard score of the given random variable x. Okay, we're going to standardize. So if I have a random variable x equal to 10, mean is 8, sigma is 4. What we can do is to standardize every single random variable into a z-score, so we can see where they're at. So at the moment, this is your random variable x. So the mean is 8. The standard deviation is 4 at a time. 10 is somewhere to the right of it, to the right of the mean. So when I standardize it, so basically I'm having myself another axis. This is called a z, where the mean is 0. Okay, mean is always 0 on, when I standardize my normal curve. Changing from random variable x to the standardized numerical value, the z-score, where we can actually look up the probability underneath the curve, okay, from a table. So when I convert x minus mu divided by 4, sigma is 4. So that's 2/4, which is 0.50. So that tells me that under the z-axis, under the z-score, mean is always going to be 0. As when I standardize it, that means this 10 is actually 0.5. Okay, the random variable 10 in terms of a z-score is only 0.5. So that means that particular 10 is only 0.5 places to the right of the mean in terms of a standard deviation. Okay, so it's only 0.5 places to the right of the mean. So when it comes to finding the area under the normal curve, okay, since a normal distribution is a continuous distribution, we will deal with interval rather than a single point. Okay, PDF, the binomial PDF we talked about in the previous topic, that's actually finding exact probability of an exact value. Since we are dealing with a continuous random variable now, we no longer will be use PDF. We're gonna all use cumulative density function, the CDF. So to measure the probability, we will actually look at a chunks of area at a time, not by a single point, but we're gonna look at chunks of area at a time. So there are 2 ways we can actually find the area under the curve. Okay, there are 2 ways to find the area on the curve. Number 1, standardize your random variable x, which means find the z-score. Then we can look up in the table or use a graphing calculator. Okay, so on the formula sheet, toward the end, you have a standard normal distribution table. Okay, this page is all the negative z-scores. And the following page is all the positive z-scores. So I can look up my area under the curve, or we call them probability, using the table, or we can use graphing calculator to help us. But notice that on the table, the area is always to the left of the z-score. So that means all these numerical value in the middle is referring to area to the left of that z-score. Okay, always referring to area to the left. So here are the 4 scenarios that we're going to run into in terms of an application. We'll be looking for the area under the curve to the left of the z-score. We can look for to the right, in between, or to the right and left of 2 z-scores. So since the table displays area to the left, so once I find a z-score and look it up the answer on the table, that is the area to the left. To the right, we will use a complement rule. So what we do is when we look up the table, when we look up when we look at the area on the table for that z-score, it's only gonna be, the answer we get is area to the left of it. So to find the area to the right, we will take 1 minus the area to the left. So this is area to the left. So this is 1 minus area to the left. That will actually give you area to the right. All right, to actually find the area in between two z-score. Okay, so what we're gonna do is look up the area to the left of the bigger z-score, because the bigger z-score covers more area to the left. Then we're gonna look up the area to the left of the smaller z-score. So the answer I get is also to the left. So to the left of this, to the left of this. So the overlapping, okay. So if I take the bigger area, subtract the small area right here, that will leave me the area in the middle. So we will subtract the two area. Okay, that's the idea. So think about it. Area to the left of the bigger z-score, which is cover more area. Okay, subtract the area to the left. So the overlap, see, the bigger z-score cover all this area, smaller z-score cover this little bit area. So the overlap right here is what we're gonna subtract. So therefore, they will leave me the area in the middle. All right, so to the right and to the left of a z-score. Okay, so that means I will find each one individually and then add up the two areas. I will find the area to the left of the bigger z-score, subtract it from 1, which is up here, to give me the area to the right. Then I'm gonna look up the area to the left of this z-score and add them up to give me the area of the two tails. All right, so let's try the example, okay? For the standard normal distribution table in the that's on the formula sheets. Find the area under the standard normal curve to the left of negative 2.27, negative 2.27. So this page, negative 2.27, the first column is the first two digits of the z-score, negative 2.2. Negative 2.2 is right here. Negative 2.27, so 7 is up here. So if I will go this way and come down, that will be this number right here. 0.0116, negative 2.27. So the row on the very top here is the second digit of is the last digit of the z-score. So 0.0116. Okay. All right. To find the area under the standard normal curve to the right of z equal to 2.38. So to the right, so number one here says find the standard normal distribution table, find the area under the standard curve to the left of it. So to find the area to the right of my z-score, I need to find the area to the left. 2.38, positive 2.38. So let's go to the other page. 2.3, and then 2.3 is right here, and then 8. Coming down from 8, 2.38. So that will be this number here, 0.9913. So this number is the area to the left. So for the correct answer one, write out the computation to find the area under the standard normal curve to the right. So to find the area to the right, we will take 1 minus the area to the left. So that will just be 1 minus 0.9913. 1 minus 0.9913. All right, probability always run to 4 decimal place, so that will be 0.0087. Okay. So if I have a normal curve, okay, 0 is here, 2.38 is here. I'm looking for the area to the right of that. So that's only 0.0087. So why so small? Well, this is almost, this is way out, this is actually to the right. Okay, it's to the right of, of 2 standard deviation. I'm saying, so this is in between 2 and 3 standard deviation. So it's real small areas right here. So remember, if on the empirical rule, let me just kind of bring it up. If I go up to empirical rule here, topic 10. So we are looking at to the right side, to the entire right side of 2 standard deviation away is 2.5%, right? So I'm looking at 2.38 something, so that's even smaller. To the right side of the 3 standard deviation is only 0.1%. 0.1% is literally 0.001. Because you got to move the decimal to the left 2 places. Okay, so that's very small. All right. Find the area under the standard normal curve between 0.19 and 2.18. So let me draw this standard normal again. So the mean is right here in the middle. 2.18 is to the right of it, and 0.19 is a little bit to the left. So I'm looking for the area in between them. So the idea here is this, okay? 2.18 is a bigger z-score, therefore the area to the left is bigger. So we're gonna find the area to the left of 2.18. We're gonna find the area to the left of 0.19 and subtract the 2. That will give me what's in the middle, what I'm looking for. So for the standard normal distribution, find the area under the standard normal curve to the left of 2.18. So let's go back to the formula, to the table, 2.18. Positive, 2.18. Uh, 2.1 and 8. I thought I could delete it. There you go. And 8 coming down. 2.18. So that will be this number. 0.9854. 0.9814. Okay. Now, number 2, I'm going to look at the area to the left of 0.19. To the left of 0.19. So 0.1 first, and then 9. 9 is right here. So that will be 0.5753. 0.5753. All right, number 3. For the correct answer 1 and 2, write out the computation. So the computation will be take the area to the left of the bigger z minus the area to the left of the smaller z-score. So 0.9854 minus 0.5753. So if you put that in the calculator, number 4, your answer should be 0.4104. 0.9854 minus 0.57. Oops, 9854 minus 0.5753. There you go, 0.10. Oh, sorry. 0.4101, excuse me. There you go. All right, so let's find the area to the left of one z-score and then to the right of another. So to the left of one, right? So the idea here is to add up the two areas, right? To find the total. So from the standard normal distribution, we'll find the area under the standard normal curve to the left of the smaller one. Negative 2.15 is smaller. So mean is the middle, negative 2.51. I'm looking for the area to the left of this z-score, and I'm looking for the area to the right of 0.11. So I'm gonna take this area plus that area in a minute. Okay, to the left of 2.15, 2.15, negative 2.15. Negative 2.1, and then 5 is right here. So that will be 2.15, so that will be 0.0158. 0.0158, okay. So that's the area of this. All right, number two, find a standard from the table, we're gonna find the area to the right of 0.11. To the right of 0.11, so that will be to find that will be 1 minus the area to the left. Because the table only gave me area to the left of 0.11. So that'll be 1 minus 0.11. Go to the positive, 0.1 and go all the way across to, oh, excuse me, 0.11. That'll be this number right here. 0.05438. So once I subtract, then I should get 0.4562. So to find the area, so number three, you want me to write out the computation. So that'll be area to the left and area to the right. 0.0158 plus 0.4562. All right, 4 decimal place. So my answer 0.4720. Okay, so that'll be the area with both total together. All right, using a calculator is a little bit easier. But it just, we gotta type it in there. So when it comes to finding the area under the normal curve or the probability using graphing calculator, we're gonna be looking for second vars. We're gonna go to second vars, which is looking for the word distribution, and select normal CDF. And once I select normal CDF, what I type inside the parenthesis is lower bound, upper bound, mean, and standard deviation. Okay, so just gotta remember this a little bit. If there is no lower bound, enter negative 1E99. E stand for times 10. Okay, so this is negative 1 times 10 to the 99 power. So that's referring to, basically, it's equivalent of saying negative infinity. Okay, so if here is a z-score, and I'm looking for the area to the left of it, what is my left bound? This left side never ends. So technically it's going to negative infinity. So there's no negative infinity in the graphing calculator. So to indicate negative infinity, we type in negative 1 times 10 to the 99 power, or this E stand for times 10 to the 99 power. So if there is no upper bound, we enter 1E99. So if I'm looking for area to the right of something, right? So how right does it go? I gotta tell the calculator to go to infinity, or we can type in 1E99. That means 1 times 10 to 99 power. Okay, so that's the way how we do the bounds. All right, so same exact z-score. I'm gonna use a calculator this time. So to find the area under the standard normal curve to the left of z equal to negative 2.27. So number one, want me to write out the computation. So that will be normal CDF, okay, to the left. So think about this, to the left, 0 is here, negative 2.27 is here. To the left of it, so my left bound got to be what? Got to be negative infinity or negative 1E99. All the way to negative 2.27, that should be my upper bound, because that's where it ends, comma 0, comma 1. 0 is the mean, 1 is standard deviation. Okay, that's what the 0 and 1 stand for. Mean is 0 for normal distribution, standard deviation is always 1 at a time. Okay, that's how it. So you're telling the calculator, I'm trying to standardize, I'm trying to find the area of a standardized curve. Okay, number 2. All right, let's see what the answer is. 1 to 4 decimal place. So second distribute, number 2, negative 1e, not the alphabetical e, but this e right above comma, ee, second ee, that's your times 10 to the 99 power, comma, negative 2.27, comma 0, comma 1. Okay, mean and standard deviation. So the area to the left is 4 decimal place, 0.0116. There you go. All right, to find the area under the standard normal curve to the right of 2.38, to the right of it. So let's say 2.38 is here. I'm looking for the area to the right of it. So that means I have no upper bound. I starting at 2.38, going looking for the area to the right. So let's write out the computation. Normal CDF starting at 2.38, comma, no upper bound. This is going to infinity, 1E99, comma 0, comma 1. All right. 2.38, comma, 1E, second comma, EE, 99. Don't use the alphabetical letter E, okay? That would not compute. Comma 0, comma 1. There you go, 0.0087. That'll be my area to the right. Okay, area in between this z-score and that z-score. So this using calculator is a little bit easier. Looking for the area in between 0.19 z-score and 2.18. So that means my lower bound got to be 0.19, my upper bound is got to be 2.18. All right, so this is how we find the area under the curve. 0.19, comma 2.18, got to be the upper bound. From here to here, comma 0, comma 1. So earlier, the previous two example, I did not have upper bound or lower bound. Okay, that's why it's keep on going. So the 1E99 or the negative 1E99 is referring to going to infinity or negative infinity. But this example, my area is from this z-score to that z-score. So the smaller z-score got to be my lower bound. The bigger z-score is my upper bound. So it'll be 0.4100. 4 decimal place. All right, to find the area under the curve to the left of negative 2.15 and to the right of it. So idea is the same, I'm saying I got to add up the two area. So this example, sorry. So I'm just gonna I'm gonna do the first one, okay? The first is equal to the left of that. to the left of it. So that's normal CDF to the left of that. So that's left bound got to be negative 1E99, comma, from the left. To the left of so that's negative 1E99 to negative 2.15, comma 0, comma 1. To the right of 0.11. So once I find each one, I'm gonna add them up. So I'm gonna put this all in the calculator. To the left plus the area to the right of 0.11. So the lower bound is 0.11, comma E1E99, comma 0, comma 1. Right? Lower bound, keep on going to the right. So that's the computation. You need to write it out or enter. So number 2, let's round to 2 decimal place. So second distribute. Okay, number 2, negative 1E99, comma, negative 2.15, comma, 0, comma 1, close parenthesis, then plus. Second distribute. All right, lower bound is 0.11. Upper bound is 1E99, comma 0, comma 1. All right, 4 decimal place, 0.4720. The 8 will make the 9 go up, so it'll be 0.4720. There you go. All right. So on the homework, number 3, I want you to enter the 4 properties. Okay, make sure you use the graphical equation to enter your 4 properties, because for the mean and standard deviation, for this standard deviation mu and sigma, I want to use, you gotta use the graphical equation to enter those. 1 and 2 is from the definition. All right, number 4, calculate standard score given that. So this one, I want you to calculate a standard score for this random variable X 96.5. So go through it, run the answer to 2 decimal places. Okay, find the Z-score for me. All right, question number 5, find the area under the standard normal curve. Okay, this one I want you to use a table. Question number 5, use a table. So be very careful. Sometimes the table value is a little bit bigger. A little bit bigger, or it can be a little bit smaller than the calculator value. The calculator value is actually the most accurate values because the table value are rounded. In between, number 7, using calculator to do it, find the area to the left. Number 8, find the area in between using the graphing calculator. All right, so just real quick showing you what it means to find the area on the normal curve and what exactly is a normal curve or normal distribution. So normal distribution or the normal probability distribution is basically saying that my data displays a bell-shaped curve. Okay, thank you for watching.